Section 12.2 Electrolytes and Nonelectrolytes. Solutes can be classified by their ability to conduct an electrical current. When electrolytes dissolve in water, the process of dissociation separates them into ions, forming solutions that conduct electricity. When non-electrolytes dissolve in water, they do not separate into ions and their solutions do not conduct electricity. To test solutions for the presence of ions, we can use an apparatus that consists of a battery and a pair of electrodes connected by wires to a light bulb. The light bulb glows when the electricity flows, which can only happen when electrolytes provide ions that move between electrodes to complete the circuit. Types of electrolytes. Electrolytes can be further classified as strong electrolytes and weak electrolytes. For a strong electrolyte such as sodium chloride, there are 100% dissociation of solutes into ions. When the electrodes from the light bulb apparatus are placed in the sodium chloride solution, the light bulb is very bright. In an equation for dissociation, the charges must balance. For example, magnesium nitrate dissociates to give 1 magnesium ion for every 2 nitrate ions. However, only the ionic bonds between magnesium and nitrate are broken. The covalent bonds within the polyatomic ion are retained. The dissociation for magnesium nitrate is written as follows. Magnesium nitrate, in the presence of water, dissociates into magnesium ions and 2 nitrate ions. A weak electrolyte is a compound that dissolves in water mostly as undissociated molecules. Only a few of the solute molecules separate, producing a small number of ions in solution. Thus, solutions of a weak electrolyte do not conduct electricity as well as the solutions of strong electrolytes. When the electron loads are placed in the solution of a weak electrolyte, the glow of the light bulb is very dim. For example, an aqueous solution of the weak electrolyte hydrofluoric acid contains mostly hydrofluoric molecules and not a few hydrogen ions and fluorine ions. As more hydrogen ions and fluorine ions form, some recombine to get hydrochloric acid molecules. These forward and reverse reactions of molecules to ions and back again are indicated by 2 arrows between the reactants and the products at the point in opposite directions. A non-electrolyte, such as sugar, dissolves in water as molecules, which do not dissociate into ions. When electrodes of the light bulb apparatus are placed in a solution of a non-electrolyte, the light bulb does not glow because the solution does not contain ions and cannot conduct electricity. Table 12.4 summarizes the classification of solutes in aqueous solutions. Strong electrolytes dissociate completely into ions, and they do conduct electricity. Strong electrolytes are such as sodium chloride, potassium bromide, magnesium chloride, sodium nitrate, potassium hydroxide, sodium hydroxide, hydrochloric acid, hyperbromic acid, hydroiodic acid, nitric acid, chloric acid, and sulfuric acid. Weak electrolytes partially dissociate and mostly molecules with a few ions, and they weakly conduct electricity. Hydrochloric acid, water, ammonia, and acetic acid. Non-electrolytes do not associate at all. They only exist as molecules and they do not conduct electricity. Any organic compounds, including sugar, is an example of a non-electrolyte.